Welcome everyone to the quick solution of All India AIATS Test Series Medical 2019. Test 9 Code A and B dated 17 February 2019, and I will discuss the physics portion. Now let us proceed to the question number 1. Question number 1 says a particle is moving on a circle of radius capital A. At an instant, its speed and tangential acceleration are capital B and capital C respectively. The total acceleration of particle at that instant is. So, the question belongs to non-uniform circular motion, and we know very well that in non-uniform circular motion we are having two accelerations. One is due to the circular motion, that is centripetal acceleration acting always toward the center of the circle, and other is tangential acceleration which acts in tangential direction. So the net acceleration A will be given by two perpendicular vectors are added by the formula AC square plus AT square here. Now in order to calculate the centripetal acceleration, we know that centripetal acceleration equals speed square divided by radius. So speed is B, so B square divided by radius is A, so A whole square plus tangential acceleration square. The tangential acceleration is given C, so that's why C square. After solving, we will get the net acceleration A equals B to the power 4 divided by A square plus C square. So student, we will proceed with option number 3. We will move on option number 3, which is correct. Now let us proceed to the next question, that is question number 2. A particle is projected from origin along x-axis with velocity v0 such that it suffers retardation of magnitude given by kx cube, where k is a positive constant. The stopping distance of the particle will be what? Now, as it is already mentioned in the question that the particle is suffering retardation, it means we can have the expression A equals minus of kx cube. Now we have to calculate the distance covered by the particle before being stopped. So we can write A as v times dv by dx equals minus kx cube. Let us rearrange the variable. We will get v dv equals minus kx cube. Integrating both sides in order to calculate the dx, or in order to calculate whatever asked in question, that is stopping distance of particle, we have to integrate both sides. So the limit of x will be, particle has started from origin, so x equal to 0 to distance covered by the particle is x, so 0 to x. Now the particle has started with initial velocity v0, so limit of speed will be v0 to particle finally got rest, so 0. Integration of v will be given by v square divided by 2 equals, with proper limits, v0 to 0 equals minus of k times integration of x cube is given by x to the power 4 divided by 4 with limit 0 to x. Now after solving, we will get minus of v0 square divided by 2 equals minus of kx to the power 4 divided by 4. 2 to the 4, and if we solve for x, we will get x equals twice v0 square divided by k whole to the power 1 by 4. So this is our final expression, and if we search for the option, we'll find that option number 2 is absolutely correct. Now let us proceed to the question number 3. Here we have question number 3. A physical quantity of dimension of time that can be formed out of small c, capital G and one more expression E square upon 4 pi epsilon naught is. Means we have to take three quantities C, G and E square by 4 pi epsilon naught. We have to combine them and we have to form the dimension of time with the help of these three. So this will be done by the principle of homogeneity in dimensional analysis. Since they are combined to form the dimension of time, so we can write m naught L naught t to the power 1 for the dimension of time, directly proportional to dimension of C to the power x, dimension of capital G to the power y, and the dimension of expression E square upon 4 pi epsilon naught to the power z. We have to calculate the value of x, y, z, and then we will get our final expression. Now, putting the dimensional formula of the expression to the right hand side, we will get C, which gives us LT minus 1 to the power x, G, which gives us m minus 1, L cube t minus 2 to the power y, and z gives us m times L cube t to the power minus 2. Now, after rearranging mass, length and time in their individual brackets, we can get three linear equations. So finally we will get what? M naught L naught t to the power 1 proportional to m to the power minus of y plus of z, L to the power x plus 3y plus 3z, and t to the power minus x minus 2y minus 2z. So therefore we got three equations, that is minus of y plus z equals 0, x plus 3y plus 3z equals 0, and minus x minus 2y minus 2z equals 1. After solving, we will get x equals minus 3, y equals 1 by 2, z equals 1 by 2. So therefore our final expression will be t proportional to, putting the values of x, y, z in equation number 1, then we will get the expression 1 by c cube g to the power 1 by 2. So in bracket g e square 4 pi epsilon naught. Since both g and e square upon 4 pi epsilon naught has the same power, that is 1 by 2. So now if we search the option according to our answer, then we will go with option number 3. Now let us proceed to the next question, that is question number 4. In question number 4 it is saying three identical cubes of mass m are placed on a smooth horizontal surface. A constant force capital F is applied on A as shown in figure. The force on capital B provided by capital C will be what? Now, if we see the diagram, we will find that the net external force acting on the system containing three blocks is capital F. So therefore we can calculate the acceleration of the system, that is F external divided by total mass, which is F by 3m. It means the system will accelerate with this acceleration, and block A, block B as well as block C, all of them will accelerate with the same acceleration. Now let us draw a free body diagram and separate the block B and C in order to identify the forces acting between them. Now block A, block B, block C. We have to calculate the force applied by C on block B. It means we have to see the forces between B and C. So let us separate B and C. There is a contact between B and C, so that is why they will exert action-reaction pair on each other. B will exert a normal reaction in this way. As a result, C will exert same normal reaction but in opposite direction this way. So now we have to calculate the force exerted by C on B, that is N. So ultimately we have to calculate the normal reaction, which we can calculate from using the Newton's second law on block C also. Net force acting on block always equals mass of the block into acceleration. We know that the net force acting on block C is equal to N multiplied by mass of block C into acceleration, that is F by thrice M. M cancel, so ultimately normal reaction is F by 3, and that is the force exerted by block C on block B. So we will go with option number 2, which is correct and matching with our answer. Now let us proceed to the question number 5. A vertical thin rod is hinged at point P. Due to the slight push, rod starts to rotate. The velocity of center of mass of the rod just after turning through angle theta will be given by what? Given that L is the length of the rod. Now as we see the question, we will find that the question belongs to the chapter System of Particle, one of the most important chapter from the NEET perspective. There are several ways to solve the question, but if you try to solve it using the energy equation, law of conservation of mechanical energy, then that will be the simplest method. So here the forces acting are conservative. Hinge reaction will not do any work. It means we can say that the work is done by only conservative force. That is why the mechanical energy will be conserved. So here, since energy is conserved, therefore initially the situation 1, finally consider situation 2. So therefore the total energy of system in situation 1 will be equal to the total energy in situation 2. The total energy in situation 1 is only potential energy it has. Height of center of mass above the ground is L by 2. So we can take the potential energy mgL by 2. No kinetic energy because it has started, equals the total energy in situation 2. Now its center of mass will lie somewhere here. This is L by 2. This is theta. So this height will become L by 2 cos theta. As a result, the potential energy in situation 2 will be mgL by 2 cos of theta, plus, since it has got some speed and it is rotating about point P, so we can have kinetic energy of rotation given by half of I omega square, where it is very important to understand I, that is moment of inertia, is about hinge, is about the point with which the object is rotating, that is end of the rod or point P. Now we can solve the expression. mgL by 2 equals mgL by 2 cos of theta plus half of the moment of inertia of a rod about one of its end is given by 1 by 3 ml square, where L is the length of rod multiplied by its angular speed square. Masses will be cancel out, length cancel out. So ultimately if we solve for omega, we will get the value of omega as under root 3 times g divided by L of 1 minus cos of theta. Now after using the trigonometrical identity, that is cos theta equals 2 sin square theta by 2 minus 1, we get omega equals under root 6g upon capital L out of the root sin theta by 2. We have to calculate the velocity of center of mass. So velocity of center of mass is equal to r into omega. Here the radius of the r will be given by L by 2 into omega. Now after putting the value of omega, we ultimately get v of center of mass, that is velocity of center of mass, is under root 3 times g capital L divided by 2 sine of theta by 2. Now if we go for the option, we will find that our result expression, final expression, is matching with option number 2. So we will go with option number 2. Now let us proceed to question number 6.